All right, guys. So today we're gonna do some two-step word problems. Save some time. You guys can read a lot of this on your own. I'm pretty much gonna be reading it as I go through the problem anyways, so I'm just gonna follow along with me. We are gonna do problems 1 and 3. If you need to rewatch this video a few times, go ahead and do so. But here we go, we're just gonna jump right into it. So, first things first, we're going to read this story. So 331 students went on a field trip to see Wakanda Forever. 6 buses were filled, 7 students traveled in cars. How many students were in each bus? Now I'm gonna reread again. I'm gonna kind of just highlight some of these key pieces of information. 331 students went on a field trip. That sounds like a pretty important information. 6 buses were filled. We don't know how many kids were on each bus, but we know 6 buses were filled. And we know 7 students traveled in cars. And then the question, I'm gonna put this in red here, how many students were on each bus? As I kind of identified some important information, we are now going to do a quick little T-chart, know and don't know. So you guys write that out. You're gonna follow along with me. It doesn't matter what order you put the information, just as long as we get the information on this chart so we can clearly understand what is going on here. So I'm just gonna go down the line here. 331 students, 331. Well, 331 students went on a field trip. To me, that sounds like a total. That is a total. There's nothing we don't know about it. It's just straight up, that's how many kids went on this trip. We know that there were 6 buses. We know there's 6 buses. I think I spelled buses wrong, but who cares, right? I think there are 6 buses, but we do not know something about this. We do not know, I'm gonna try to write this nice and small here, how many on each. And I don't know about you guys, but a lot of times I don't understand something, I'll just give it a variable. In this case, I'm just gonna give the variable X. 6 buses went, they were filled with students. We don't know how many students were on each bus. Cars, there are 7 students who rode in cars. We know everything about that. 7 students went in cars. There's nothing we don't know. We just organized all my information. Now, since we just organized this information, we are now going to logically set up an equation, okay? There are many ways you can do this, and your equations might look different than mine, but I'm gonna start with the equal sign, and I always put my total off to the right. So in this case, I know my total is 331 students. On the left side, we're gonna pretty much write this story and how we got to 331 students. So we know that there were 2 things. There was kids on buses, and then we know that there were kids in cars, and if we put them together, that'll be my total. So let's see here, 6 buses. 6 buses were filled. Well, I know there are 6 buses that went, but I don't know how many kids were on each bus. If I knew, I can multiply it by 6, so it looks like I should do a 6x here. If I knew how many students were on each bus, I can multiply it by that 6, and then I would know the total number of kids who went on each bus. I like that, looks good. 7 kids went in cars, plus 7, right? I'm just adding 7 more because 7 additional kids went with a car. Look at that, 6x plus 7 equals 331. 6 buses went with the X number of students. If we multiply those together, that would give me my total number of bus students. Plus 7, 7 is my total number of car students. I add them together, it'll give my totals total. This right here is it's not our answer, but this is my correct equation that I got from reading this information. And now from here, I'm just gonna solve it. Kind of, blast in the past, we got some notes. So as I solve this problem, does it have any parentheses? No. Can I combine like terms? Well, here's my equation bar. On the left side, I have a variable, no variable, can't combine them. On the right side, there's only one thing, so no, I cannot. Is my variable already on one side? Yes. So it looks like we're just gonna be doing step 4. We're going to add or subtract to move our constant, multiply or divide to move our coefficient, and we should be finished. So let's do that. Now, my variable is on the left-hand side here, so I'm gonna worry about this side of the equation. I know that this 6 is attached to an x, so this is going to be my coefficient. Beep, beep. And then this is not attached to a variable, so I know this is my constant. So we're gonna move the constant first. It's a plus 7, so I will do a minus 7. Minus 7 on both sides. Draw my line. Those cancel, which is why we did it. Bring down my 6x. 331 minus 7 gives me 324. Now, I need to go ahead and I need to solve this. So I need to move this coefficient. It's 6 times x, so I do the opposite, which is divide. Divide both sides by 6. Go ahead and do my 324 divided by 6, and I get 54. X equals 54. So after I just move my constant, once I move my coefficient, I now get an answer of 54. And what does that mean? That means that on each of these 6 buses, there were 54 students. Done deal. Answer the question. We are done. Look how easy and fun that was. Now let's do a second one. I'm going to do problem 3. Same concept. I'm going to read it. Gertrude lost half her precious math books in a fire. So sad. She bought 13 more, which brought her to a total of 45 books. With how many did she start? Well, she lost half of her books in a fire. That sounds important. She bought 13 more, and she had a total of 45. So let's write this down. So we have 45, to me, that is a total. She bought 13 more. So 13 is, she bought 13 more. And again, total 45, there's nothing we don't know about that. Her buying 13 more, there's nothing we don't know about that. But this lost half. She lost half of her books. Well, what we don't know about it is how many she had in the beginning. How many she had. We don't know how many she had. If I knew how many she had, it'd make a little more sense. But we just know she lost half of what she had, and we don't know how much she had. So let's take this information, throw it together in a nice equation. So, got my equal sign. My total is 45. I just always put my totals on the right. You don't have to. That's what I do. Let's start this half, because this thing is really annoying me. Let me see here. So if I don't know how many books I had, I can say I have X number of books, right? So let's say I have X number of books. If I lost half of them, well, let's see here. If I had 10 books, half of that would be 5. If I had 20 books, half of that would be 10. If I had, say, 100 books, half of that would be 50. I'm getting my numbers by dividing by 2. So I can divide this by 2, and that perfectly represents what's happening. I had an X number of books, no clue how many. Divide that by 2. But now I got to add this 13 here because she bought 13 more. So she bought 13 more. So this right here, I think is going to help me solve my question. How many books did she start with? We don't know how many she started with. X. We divided by 2 because she lost them in a fire. She bought 13 more, and her ending total is 45. Let's solve it. And this right here, guys, just so we know, this is my correct setup of an equation. Well, here we go. I got my equation bar. Parentheses, I have no parentheses, so we can skip them. Combine like terms. Well, on the left side, I have a coefficient and a constant, meaning I have one attached to a variable, one no variable, can't combine them then. This is all alone, so there's nothing to combine there, so I guess I can skip 2 as well. Variable on one side, variable is already on, it's on the left-hand side, it's already on one side. And I'm giving you guys some easy equations. So it looks like we're gonna do step 4. We're gonna add or subtract our constant, multiply, divide our coefficient, and we should be done. And again, we're gonna focus on the side where the variable is. So on this side, 2 is attached to a variable, that is a coefficient. 13 is not, that's a constant. Let's attack that first. It's plus 13, so I will minus 13 on both sides. So let's see here, 45 minus 13. So that equals 32. I can bring down my x over 2 because those 13s cancel, which is why we did that. And now I just gotta move this next 2 right here. And this 2 is we already said it, a coefficient. It's x divided by 2, so I'm gonna do the opposite. I'm gonna times by 2. 2's cancel, which is why we did it. X equals 32 times 2, 64. That is my answer. And before we move on, just want to talk about it. So that means that this Gertrude, what a great name. That is a gorgeous name. She started off with 64 books. Then she lost half of them in a fire. After buying 13 more, that would give her a total of 45. So practice makes perfect with these word problems. These know and don't know charts, you're not always going to have to do them, but in the beginning, it will help if you make them. Set your equation up, try it out. You will do the rest in class. Whoever's not done his homework, have a great day.